Welcome to yet another lecture in engineering mechanics. Today we are going to see rectangular component system. What is rectangular coordinate system? If you see in this figure, a force F is shown as sum of two forces Fx and Fy. The axes x and y are also represented. That means the forces are resolved in the x and the y direction as shown in this figure. So in many problems, it will be found desirable to resolve a force into two components which are perpendicular to each other. The force F has been resolved into a component Fx along the x-axis and Fy along the y-axis. The parallelogram drawn to obtain the two components is a rectangle. We have seen in parallelogram law of vector addition, two forces sum up to form a resultant force, and the two forces form the sides of the two parallelogram. So in this case, the two sides are Fx and Fy, and they are perpendicular to each other. That is the difference between any other resolution to the rectangular coordinate resolution. So Fx and Fy are called the rectangular components of this force given here as F. Here you can see this force is represented in the x and the y direction as shown as horizontal and vertical. The same force can be represented in a different way, that is in the inclined x and y axis. Please note the axes x and y are perpendicular to each other. The x and y axes are usually chosen in the horizontal and the vertical axis respectively. They may, however, be chosen in any two perpendicular directions as shown. The students should think of the construction line as shown in the figure as being parallel to the x and the y axis rather than the perpendicular to this axis. So if you ask me, how do I get the rectangular components, or even if it is the resolution of force in any other direction, it would be rather very simple. If you see here, I drop a line parallel to my given y-axis onto the given x-axis. So this line, wherever it intercepts the x-axis, that is the length of your x component. Similarly, I have dropped a line parallel to the x-axis, which is shown here, and wherever it intercepts the y-axis, that line is taken as the y component of the force. For this inclined position also, I have not taken the horizontal and vertical direction. Rather, I have chosen simply a line parallel to the given y-axis and line parallel to the given x-axis. Thereby, it helps me in resolving the force in any given rectangular component system. These kind of rectangular component systems are very useful when you try to solve problems of inclined planes or maybe a wedge friction problem. This practice of drawing parallel lines would be helpful in determining the oblique components, like as shown in the below figure. Now let us see how to define the forces as components. If F is the force given, Fx is the x component of the force, Fy is the y component of the force, and if the force makes an angle of theta with respect to the positive x-axis, then we can say Fx, the magnitude, is equal to the magnitude of the force into cos theta, and Fy is the magnitude of the force into sin theta. In the vectorial form, I can say Fx is the magnitude Fx, that is this one, I cap, and Fy is magnitude Fy, j cap. It is interesting to note the I and the j cap are also known as the unit vector along the x and the y axis. And here also the small letter f represents the magnitude of the force. Let us take an example here. This force of 800 Newton is acting at an angle of 35 degrees with respect to the horizontal. But if you want to define the component of the force in the x and in the y direction, you need to take the angle with respect to the positive x axis, and then only you may be able to apply the formula fx is equal to f cos theta and fy is equal to f sin theta. The interesting thing to be noted is that if you take the angle with respect to the positive x-axis and measured in the counterclockwise direction, your chances of making a mistake in finding the x and the y component reduces a lot. Next comes the important thing, that is, how can we find resultant of multiple forces with the help of the x and the y components. Let us consider here three vector force P, Q and S acting at a single point A. So we know that the resultant force R will be P plus Q plus S. The easiest way is to resolve these forces in the corresponding x, y directions. So here, as you can see, the force P is resolved in its Px and Py direction. Vector S is resolved in the Sx and the Sy directions, and Q force is resolved into Qx and Qy direction respectively, which leaves us with a simple formula to find the resultant force as a vector. Rxi plus Ryj, that is the vector proposition for the resultant, which is equal to Pxi plus Pyj plus Qxi plus Qyj plus Sxi plus Syj. If I group the I components and the j components, the equation would look like Px plus Qx plus Sx into I plus Py plus Qy plus Sy into j. Thank you for your patient listening. I hope you are able to follow the lectures. Please do leave your feedback in the form of comments. It will be great to receive good and bad comments. If you are not able to follow my lectures, please do feel free to contact me anytime. Thank you.